Hello everyone, this is a UVC sterilization assistive bot. Maintaining sterile environments in hospitals is essential to prevent the hospital-acquired infections. This project presents an autonomous UVC sterilization robot designed to disinfect surfaces using UV LEDs and ensure real-time pathogen detection. By combining automation and UVC technology, the robot aims to reduce infection risk and improve hospital sterilization processes. Additionally, the system features a drug reminder function to help patients adhere to the medication schedules and provide assistive support for individuals. The objective of our project is implementing an UVC light for effective germicidal action to reduce hospital-acquired infections, enabling autonomous navigation with obstacle detection using ultrasonic sensors, ensuring safety by automatically turning off the UVC light when human is detected nearby, providing real-time monitoring and control through an IoT-based interface, incorporating a drug reminder system to assist patients, particularly those with chronic conditions. Hardware description. This is the on-off switch and this is the 6-volt battery. So this is the boost converter that converts the 6-volt battery supply into 12-volt battery supply, giving us the input to the Arduino. Arduino is a microcontroller based motherboard. It used best for the simple repetitive task, which is best for beginners to understand well, and it is cost effective. Drive, which contains an IC L293D IC that controls the 4 wheels of the robot. MP3 player with the SD card attached to it. This system features a drug reminder function to help patients adhere to the medication schedules and provide an assistive support for individuals. These 4 wires are to control the wheel of the robot. This is for forward, backward, left and right. This is the speaker and this is the RTC, which is the real-time clock that used to display the real date and time in an LCD display. And coming with this is the node MCU and this is the heatsink and this is the MOSFET. Heatsink is a component that is designed to absorb and dissipate heat away from the source. This node MCU communicates to the mobile app through Wi-Fi or Bluetooth that reads the data and give input to this Arduino and controls the UV light. So MOSFET, it is kept near the node MCU, which controls the LED light. This is the MP3 player with the SDD card and the reader. This is an ultrasonic sensor to enable the real-time obstacle detection and ensure safe navigation during the operation. So coming with this is the color sensor. This is the TCS34725 that detects the intensity of the reflected and emitted light in the RGB spectrum from the surface. That cleans the surface will reflect light differently than contaminated ones. Now below the robot, these are the UV light and this is the DC motor that drives the 4 wheels for the forward, backward, left and right direction, and this is the robot case. The software description part, for which we should on the robot and we should connect the Bluetooth through mobile phone. So this is the app that we had invented and with the help of MIT app inverter to control the function of the robot. So this is, let's connect the Bluetooth first. Now it is connected to the device. Here we have the arrow keys, terminals, accelerometer, button and slider, and voice control, everything we had inbuilt. So in which button we had given here as star F hashtag, which means forward. That means the robot gets the instruction as a data that moves the robot in forward direction. Likewise, this is star B indicates the backward, star L hashtag indicates the left, and star R hashtag indicates the right, and this is for stop, and this is for UV light on and off. Okay, it is the so now when it is clicked as forward, the robot moves forward, and when it is given a stop command, the robot stops. Likewise, giving a backward command will move the robot towards the backward direction. So this is stop, it indicates stop the robot. This is the left command through which robot tilts towards its left side and moves further. Again we give the stop command, then now the robot is turned towards, giving the right command, the robot turns towards the right. This is the command. Light. On pressing the UV on off light command, so the UV light blows. Let us test the robot function in obstacle detection. So this is the obstacle, and let us test how this robot detects this obstacle. But how the robot is giving the medical reminder, for which we have to connect the Bluetooth first. So it is connected. Here in the terminal we have to give input as like star if morning means capital M, and the time here it is 11:27. So let me give it as 11:28, and this is hour and minute. Then we'll give hashtag. So we'll send the data. So here it is indicating as M. So with the time of 11:28, it will give a buzzer, so that it will indicate that a patient to take the medications. So this is the buzzer that intimates the patient to take the medicine. To run a robot, we have created an app using a MIT App Inventor, through which we are connecting it through Bluetooth. Now it is connecting through Bluetooth. Let's connect our device, that is BT04A. Now it is connected. This is the front end work we have done, which includes all the. Now let's click the button and slider key to operate the robot in forward, back, left, right, and stop and on off the light. Now let's see how the robot works for the medicine reminder. First, for which we have to connect the Bluetooth, and in the terminal we have to enter the data as like star if morning means M, night means N, then hour, minute, followed by the end with the hashtag. Then input data is sent to the robot. Now the UV light is turned on, and now the robot is moving in its backward direction. Now it is moving in forward direction. Now the robot is tilting towards its left side. Now it is being tilted to its right direction. Now the input data is sent to the robot, and that will be indicating as capital M in the LCD display. After which, at the given time, it will be indicating giving a buzzer, a beep sound. Let us test the robot function in obstacle detection. So this is the obstacle, and let us test how this robot detects this obstacle. The obstacle is kept in front of the robot. Within the distance of 1 meter, the robot is able to detect the obstacle. Now the robot is turned on. Once it detects the obstacle, it turns off the UVC light and displays as obstacle found in the LCD display. Also mentions how much distance it is apart. Now let's see how the robot detects the pathogen. In our UVC sterilization robot, the LCD screen shows the values labeled as R, G, P and C, which come from the TCS 34725 color sensor. This sensor measures the light intensity in 4 channels, that is red for R, green for G, blue for B, clear C, that is for total light intensity. It contains an RGB filter and an IR blocking filter, allowing it to detect the accurate color data under different lighting conditions. Red measures the intensity of the red light reflected from the surface. G, green, measures the green light. B for blue, measures the blue light. And C for clear, measures overall ambient light intensity, that is sum of all visible light. Our UVC sterilization robot is used to indirectly monitor the surface cleanliness. After sterilization, the surface reflects the light differently. If pathogens like bacteria or biofilms or organic residues remain, light absorption and reflection will change. The RGB values will be altered by the differences. It will be altered by these differences. For example, high organic matter might absorb more light, reducing the RGB values. A clean surface will reflect the more uniform light, possibly increasing the RGB values. The clear C value is especially important because it shows the overall brightness. A low C values after sterilization might indicate the leftover contaminants. A high C value usually indicates the cleaner surfaces. Now our robot works by taking a baseline for RGB and C readings before sterilization and another reading after UVC exposure, comparing the values to detect the level of cleanliness. The significant change indicates the effective sterilization.